Hey gang, welcome to the edition of 10.3, which is two-way tables and probability. We've actually already looked at a couple of two-way tables as we've done problems, so we're just going to jump right in. And this is what a two-way table looks like. So you would have some information across the top, some information around down the side. So here we have method of arriving and whether they were on time or tardy. And we have these total column, like a total column and a total row down here, that if I added up everybody who's tardy, that would be this many people, the people on time, here we go, people who use the city bus, and the people who walk. And so what we want to do to begin with is just fill this out by kind of working backwards. So if we look here, if we look at total down this column, these two numbers are going to have to add to be 130. So if we have 60, then the rest of the 130 needs to be at the top here, and that's going to be 70. Okay, and then if we want to look down here at the bottom, these two numbers need to add to 130. We already have 58, so what's left out of the 130? That would be 72. And then we can fill out the inside. So these two need to add to be 70. So what goes here? Hopefully you said 48. Okay. These two need to add to be 72. So if we have 72, we take away 22. What do we have left there? That would be 50. And then in our last box, either we have to look this way, these have to add to be 58, or this way they have to add to be 60. And that would be 10. All right, see, just work backwards. Why don't you go ahead and pause and make sure you can do number 2 here. All right, hopefully you got those answers and we're moving on. So on number 3 here, we're actually going to make our own two-way table. So a survey was taken of 100 families with 1 child and 86 families with 2 or more children to determine whether they have a savings for college. Of those, 94 of the families with 1 child and 60 of the families with 2 or more children were saving for college. We want to organize the results in a two-way table and then talk about, find and interpret what are called the marginal frequencies. So kind of up to you how we begin. I'm going to do family size across the top. So we're going to do like families with 1 children or 2 or more children. And then yes, they're saving for college, or no, they're not saving for college, just to shorthand it here. So if I look through my information, it says a survey was taken of 100 families with 1 child. So with 1 child, there were 100 families. And 86 with 2 or more children. So 86 families of 2 or more children. So this total down here, this is the total of like how many families there were. And there's 186 total families that they surveyed. Of those, 94 of the families with 1 child were saving for college. So up here, 94 were saving for college. That means 6, because it has to be a total of 100, were not saving for college. 60 of the families with 2 or more children were, which would mean 26 were not. And if we finish filling out our totals, across the top, we're going to have 154, and then up next, we're going to have 32. So if it asks you to make a two-way table, there you go. And then we want to find and interpret the marginal frequencies. So what we'll get in on the next slide is actually, we already found the marginal frequencies. The marginal frequencies is just the sums, or the totals. So if we look at this, like one of the marginal frequencies, there's 154 families who are saving for college. Like that's one thing. Or there are 32 families not saving for college. There's 100 families total that were surveyed. There's 100 families that had 1 child that were surveyed. 86 families had 2 or more children that were surveyed. 186 families surveyed in all. And just that data, just looking through what this data is, this data and this data, those are your marginal frequencies. So let's look at that definition. So there's 3 vocab words that we're going to look at today. The first one is joint relative frequency, and that is the ratio of the frequency, and frequency is just how often things occur. So the ratio of the frequency that is not in a total row or total column to the total number of the values. So this is a whole lot easier than this sounds. This is going to be like the families with 1 kid who are saving for college over, because that's the ratio, over the total families. That's all it is. The number in the spot you're looking at over the total, and that's your joint relative frequency. Your marginal relative frequency is the sum of the joint relative frequency in a row or column. So if we take the joint relative frequency and we add them up, then we get the marginal relative frequency. Okay. Up next is conditional relative frequency, and it is the ratio of the joint relative frequency to the marginal. So if we take the joint relative frequency and put it over the marginal relative frequency, then we'll have the conditional relative frequency. I know there's a whole lot of words here. We're going to do an example though, and hopefully that will make sense. All right, so note those and kind of what they say. Okay, and let's look at that. All right, looking at number 4. In a survey, 214 ninth graders played video games every day of the week, and 22 ninth graders did not play video games every day of the week. Of those that played every day of the week, 36 had trouble sleeping at night. Of those who did not play, 7 had trouble sleeping at night. So we're going to make a two-way table that shows the joint and marginal relative frequencies. So we're going to start out with just, let's make a two-way table. And I'm going to make it a little bigger because I'm going to have to write some more words in it. All right. So actually what I'm doing is I'm making it kind of longer. Let's see if I can fit all what I need to fit in here. So we're going to say this is going to be played every day or not every day. And how do I want to do this other one? Let's do trouble sleeping and no trouble sleeping. All right. So we're just going to make it just like a regular two-way table. 214 ninth graders played video game every day. So every day was 214. I'm going to try just to take up a little bit of that space there. And then we had 22 who did not play every day. Okay. And then of those that played every day, 36 had trouble sleeping. So trouble sleeping would be 36. And so then not trouble sleeping would be 214 minus 36. So we have 178 did not have trouble sleeping. All right. And 7 had trouble sleeping who were not playing every day. So 7 had trouble sleeping, which would leave 15. So if we finish our two-way table, we have 43 that have trouble sleeping. And we have 193 that do not have trouble sleeping. And if we add 43 and 193, we get 236, which should be the same thing we get if we add 214 and 22. So that's just our two-way table. All right, so let's look at the joint relative frequency. I'm going to do this in green. So the joint relative frequency is the ratio of the frequency that you're looking at over the total. So for example, the joint relative frequency that goes here. So this is going to be the joint relative frequency for those that play video games every day and have trouble sleeping. We are going to do 36 over 236. So that's how many we're looking at in this spot over the total. And if we do that in our calculator, we get about 0.153. Okay, so then if I want the joint relative frequency of not playing every day and trouble sleeping, we're going to do 7 over 236. So we're doing the spot we're looking at over the total, and that's going to give us about 0.03. Okay, 178 over 236 is 0.754, and 15 over 236 is 0.064. Those are the joint relative frequencies. All right, to get the marginal relative frequencies, you can actually do it two ways. Your definition says it's the sum of the joint relative frequencies, so you can actually add these green together and make this last number here, or you can take this number, in this case 214, over your total, and I'm going to do these here in red. So if I add 0.153 and 0.754, I'm going to get 0.907. If I add 0.03 and 0.064, I'm going to get 0.094. If I add, so going across now the top, 0.153 and 0.03, I'm going to get 0.183. And if I add 0.754 plus 0.064, I'm going to get 0.818. Now, if you add these together, or you add these together, you should get very close to 1, or exactly 1, because you're talking about 100% of your people are accounted for here, and 100% of the people are accounted for here. So we should be able to put a 1 right there. Okay, so the green represents the joint relative frequencies, the red is the marginal. All right, and number 5. For financial reasons, a school district is debating about eliminating a computer programming class at the high school. The district surveyed parents, students, and teachers. The results are given as a joint relative frequencies in the table. So really what you're looking at is this is that percent, how many over the total, but we don't know the totals. What we're looking at in this table are your joint relative frequencies. So if we add those, we'll actually get your marginal relative frequencies. Okay, so if I add 0.58 and 0.06, I get 0.64. 0.08 and 0.15 is going to be 0.23. 0.1 and 0.03 is 0.13. And going across the top, 0.58 and 0.08 and 0.1 is going to be 0.76. And then 0.06, 0.15, and 0.03 make 0.24. So what I have written in red here, these are your marginal. Marginal is written in red. What we're actually trying to find here are your conditional. And if you go back to your definitions, your conditional is the ratio. Conditional is the ratio of the joint over the marginal. So the joint is what's already in black in the table. The marginal is what's in red. So if I want the probability that a randomly selected parent will vote to eliminate the class. So 0.58 is the joint. Those are the ones who want to eliminate the class, over 0.64. And I picked that because I'm just looking at the parents. So if I come down this first column, this is who wanted to eliminate out of this many. Okay, so 0.58 over 0.64 gives us a total of 0.907. That is my conditional probability that they're going to want to eliminate the class. And this really is because we didn't get 100% responding. So this is what we're doing conditional. For B, what is the probability that a randomly selected student will not want to eliminate the class? So if we look at the students who don't want to eliminate the class, we're looking at 0.15 who do not want to eliminate the class, out of 0.23, okay, because that's my marginal for the students, and I get a total of 0.652 as my conditional probability of those that want to not eliminate the class. And up last, it says determine whether voting to eliminate the class and being a teacher are independent or dependent. So do you think that the probability that people want the class to be eliminated and the probability of the teacher wanting the class to be eliminated, do you think they affect each other? And really probably the answer is no, they don't affect each other, so they are independent. Maybe unless you're the teacher of that class, right? All right, that's what I have for you today. If you have questions, see me on one of our lives or email me and we'll get that taken care of. Have a great day.